Good morning and welcome back to my channel, and in this video we're going to be tackling the big one. We're going to be deriving the derivative of e to the x by first principles. So, first of all, we have that f of x is equal to e to the x. It's fairly simple so far. F dash of x is equal to x e to the x plus h minus e to the x all over h, and that is the limit as h tends to 0. Then the next step, fairly self-explanatory still, is e to the x times e to the h. So I've split this here up using the fact that if you multiply indices with the same base, you add the indices. If you multiply two things with the same base, you add the powers, you add the indices. E to the h minus 1 over h, and that is the limit as h tends to 0. I've just taken out a factor of h. Of e to the x. And that will be equal to e to the x, because it's a constant, times the limit, this dot just means multiply, times by the limit of h tending to 0, e to the h minus 1 over h. Okay, this is where it starts to get more complicated. We're going to use a substitution for h. So let n equal e to the h minus 1. Therefore, e to the h is equal to n plus 1. Therefore, h is equal to ln 1 plus n. I'm writing it in as 1 plus n because that will make it more easy when I have to use a Maclaurin series later. Okay, so going back to our original equation, that will mean I have e to the x times the limit as n tends to 0, because I'm now working with n tends to 0, of e to the ln 1 plus n, I'm writing these out single step at a time, minus 1 all over ln 1 plus n. And that will be equal to e to the x times the limit as n tends to 0 of e to the ln is just 1, so I just take the power down. So that will be 1 plus n minus 1, so that will be just n on the top, over ln 1 plus n. And what we're going to do now is we're going to take that to the denominator by saying that if we divide by a fraction, it comes up on the numerator. So e to the x times the limit as n tends to 0 of 1 plus n, I'm writing out the denominator first, times the ln of 1 plus n, and that is the denominator of that. Using laws of logarithms, I can now take this up and put it as a power. So I have e to the x times the limit as n tends to 0 of 1 over, that's appallingly written, ln 1 plus n to the 1 over n. And now, because all the n's are in this area here, I can put the ln in there as well. So that is e to the x times 1 over ln times the limit as, ln of the limit as n tends to 0, 1 plus n to the 1 over n. Now, this is where we have to start using Maclaurin series. So 1 plus, I think it's 1 plus x to the n can be represented as 1 plus nx plus n minus 1 over 2 factorial times x squared plus n times n minus 1 n minus 2 over 3 factorial times x cubed, and so on. This time we're dealing with 1 plus n to the 1 over n, and that will be 1 plus n over n plus 1 over n times 1 over n minus 1 times n squared over 2, and you get the idea. So just substituting 1 over n in for n, and substituting n in for x, if that makes sense. And if you evaluate this and you let n tend to 0, what you get is, I'm going to write the limit as n tends to 0, what you get is 1 plus 1 plus 1 over 2 plus 1 over 6 plus 1 over 24, and more terms if you went that far. And what you can represent this as is the sum of, draw my sigmas properly, the sum of from k is equal to 0 to infinity, for some constant integer k, of 1 over k factorial. Now, that's all very fancy, but it doesn't seem to help us get anywhere. However, it does if we remember that the sum of from k equals 0 to infinity of x to the k over k factorial is equal to e to the x. It's a convergent series, which means it tends to a value, an exact value, and so this will tend to e to the x for all x belonging to the real numbers. And so applying this to our case up here, what we really have is x is equal to 1. So what we're saying is that this is, if x is equal to 1, this is e to the 1, which is just e. So back to our original case, we will have e to the x multiplied by, f dash of x is equal to e to the x multiplied by 1 over ln e. And what ln e is, because ln is just a log base e, log base e of e is just 1. So we have e to the x multiplied by 1 is just e to the x. And that is that. So thank you for attending this video, and I look forward to seeing you all next time.